Welcome to In 5 Minutes. Let us now start discussing the detector circuits. Detector was one very important block in the receivers, in TRF receiver as well as in super heterodyne receiver. After the signal is thoroughly amplified, it is given to the detector block. The function of detector is to take the modulated signal and extract the original modulating signal out of the modulated signal. An output of the detector is then given to pre and power amplifiers and given to the final output device after that. So detector forms a very important part of the receiver. Right now we are going to discuss simple diode detector, which is also called envelope detector, which is the detector used in the super heterodyne receivers of DSB-FC systems. So in double sideband full carrier, the receivers that we have discussed, we will be using the envelope detectors. As the name suggests, this circuit will try to detect the envelope of the input signal. And this is already clear to us by now that the shape of the envelope in my modulated signal is nothing but the shape of the modulating signal, because that's the definition of amplitude modulation. The amplitude of carrier was changed in proportion to amplitude of modulating signal. So the envelope, which is nothing but the set of peak values of the modulated signal, looks exactly same as the modulating signal. So if I can design a circuit which extracts the envelope from the modulated signal, then I can use that circuit as the detector circuit. It is called envelope detector for the same reason. It is also called simple diode detector because there is a single diode which we are going to use. This is a simplified circuit. The actual circuit which is used in the practical receivers will have few more components, but the basic operation we can understand by taking this three standard components. So we will look at the practical circuit in the next video clips. Let us discuss how does this circuit going to operate and give us the modulating signal from the modulated signal. There is a single diode, resistance R and capacitor C. You can see that the diode will be forward biased only when the voltage at its anode is more positive compared to voltage at its cathode. If I assume ideal diode, then my anode should be positive with respect to cathode for diode to be forward biased. Once forward biased, the ideal diode will act as a short circuit. But on the other hand, if the anode voltage is less than the cathode voltage, that means if the anode voltage is negative, because the cathode voltage will remain zero, if the anode voltage is negative, then the diode will be reverse biased, and if it is reverse biased, then it will not allow input signal to go to the combination of R and C. So why do we have this diode in the very beginning? The incoming signal is double sideband full carrier signal. We have already seen the shape of DSB-FC signal. It has got two envelopes, the positive envelope and the negative envelopes. Both the envelopes can give us the original modulating signal. But right now, when we discuss the working of simple diode detector, we will try to extract the positive envelope. And because of that, we are connecting diode facing its anode to the input side and cathode to the output side. So now, whenever the input signal is applied, only the positive cycles will make anode positive with respect to cathode and diode will become forward biased.